All right, we're going to take a look at the second part of the review for the square root functions. Primarily, this is going to look at how to solve equations that involve the radicals and not really anything going on here with graphing. For each of the three questions that I'm going to demonstrate here, I've already begun the part just to save a little bit of time, but I'll describe how I get to those. In the first question, what's really cool about this is the entire left side of the equation is within a radical and the entire right side of the equation within a radical. So in your first step, what you'd want to do is square both of the sides, and when you do that, the radicals actually just cancel out. So in a way, it's almost like you just get to remove them because they're on both sides of the equation. That ends up giving you a really simple linear equation to take a look at here. All right, now as I move things around, the negative 2x, what I'm going to do is add it onto this side because that'll bring that up to a positive x. And since my x is here, I'll just go ahead and add the 1 onto the 3, which is going to give you a 4. And that's pretty much it for the algebras finding the answer. But regardless of how short a problem is or how long a problem is, if it involves radicals, you definitely want to go back and plug those numbers in just to make sure everything is good. So I'm going to do a quick little test here. If I were to plug the 4 into the left side, I'm going to get square root of 3 minus what would be an 8 because of the 2 times the 4, and that gives me a negative 5 inside. Now right there at that point, what we're going to say as far as this unit is concerned, that this is not going to produce an answer because we don't want to get into the concept of imaginary numbers. Now the other side, you should still check it anyway. We're going to have the negative 1, and then when the 4 goes in, you're going to get a minus 4. Okay, so the two sides do end up becoming exactly the same thing. For this, we're going to still say that there's no solution. Actually, I'm going to write it this way. There's no real solution. Now, just in case you get freaked out about that, there isn't any intention to put that on the test. It was a consequence of something that was on the review. But for the test, we'll make sure that what you'd more likely come up with is maybe the square root of negative 5 versus something like square root of positive 5, where there is something different about the two of them, and then we're really confident that that's not going to be the right answer. So that's a little bit of an odd thing there. Definitely pay more attention to what I did at the beginning, just so that you can get that answer. And don't forget to check them though. All right, for the second equation, you are going to square both of the sides so that you can remove that radical, which I'm showing here just at the 4x minus 12. The other side, though, you've got to square that one too. And the thing about it is be very, very careful that you are not just trying to square the x and squaring the negative 3. Okay, you need to think that the whole binomial is going to multiply by itself, which means you got a lot more distribution. Some people call it FOIL. You're going to have the x times x, which is x squared. You're going to have a negative 3 times an x. You're going to have another negative 3 times an x, which gives you negative 6x, and then you also have that negative 3, which is the 9. But it's that term. If you don't do this right, you're going to lose that term, and ultimately your answers aren't going to work. You're never going to get right answers. You can think everything is a no solution if you do that. All right, we do end up with a quadratic here, so I'm going to keep that x squared on the right. The 4x is going to get subtracted over, which will give you negative 10x. The 12 is going to get added, which is going to get you to 21. And of course that equal to 0. All right, we hope that these can factor. And yes, the intention is that you're going to be given problems that do factor, because we don't want to turn this whole thing into then like a quadratic formula type question. Okay, and it does factor. You're going to get an x minus 7 and an x minus 3. All right, and you can go through that and check and see why that all makes sense, and that'd be a good exercise for you if you don't remember all your factoring. Okay, so that gives us a couple possible answers. We could have a 7 or a 3. Those are two different possible answers that are available. But what we're going to do is go back to the beginning. We're going to plug those values in and see if they do work out, okay? So I'm plugging the 7 into this. I probably could have done that as mental math, but I'll let you see it. You're going to get a 28, which is subtract 12. That gives you 16. Okay, square root of 16, which is 4, and I'll just leave that be for right now. On the other side, oh, that one's real short, just doing 7 minus 3, which is going to give you a 4. And yes, the square root of 16 is 4, so that answer definitely checks out. By the way, when you're doing these, you should really be thinking this is like a question mark, like, do these things actually equal? So don't make the statement that they are, because we're trying to verify that this is a true thing. All right, now testing the 3. Okay, in my radical, I'm going to have that 3 multiplied by 4, which is 12. 12 minus 12 is 0. You already know that's going to turn out to be 0. And guess what? 3 minus 3 is also 0. So that checks out as well, and you get to keep both of those as solutions. You could have no solution. You could have 1. You could have 2. You just have to test them to find out. All right, for our third one, this is the bigger guy. Not too different than what happened in the first, but it just extends a bit further. Actually, in comparison to problem number 7 that you saw, the big difference here is you get this 1 minus. Because you have that, you can't just say that we're going to square both of the sides and then drop off the radicals. It doesn't work. You get to do that on the left, and there's my y plus 2. But on the right, you need to multiply all of this by itself. And you get more when you do that. Okay, you're going to have the 1 times 1, which is your 1, fine. You're also going to get that radical part multiplied by itself and the canceling out the radical, that happens. But you get those in-between values as well. You're going to get that 1 multiplied by the negative radical. You're also going to get the negative radical multiplied by the 1, ultimately giving you 2 of them. So I write it as negative 2 square root 3y plus 7. From here, and go ahead and expect these are all going to turn out the same way. Okay, when you have that extra number there, or maybe there's like a plus something at the end, that's going to happen in this case. From this point, get everything away from the radical. Okay, so I got the y plus 2. I'm just going to go ahead and subtract the 1 to the other side. Don't do anything with this because it's attached to your radical. We're going to subtract the 3y. We're going to subtract the 7, and then all you'll have left on this side is your radical. Now, clean all that up. You get negative 2y, negative 8, so negative 6 is equal to negative 2 times your radical stuff. Okay, then from here, if that number that's in the front, if it exists here, if that number is there, and you can divide it into everything, yeah, and these are all even, then I would just go ahead and divide it out, and we get a really nice looking problem here, well, compared to what it was. Okay, divide each of those by negative 2, that's going to give you positive 3. Now this actually looks like what we had in 8 at the beginning. So we finally get to a point that's going to mimic that work. Okay, so we're going to square again. This side's going to give you a y squared plus 6x plus 9 is equal to 3y plus 7. Remember, this is the binomial getting squared out, and you get those extra terms in the middle. The radical just drops from there. I run out of space, so I'm going to move it somewhere else. Let's just place it over here. We'll say we got y squared plus 3, look at that, change my letter in the middle of a problem. We're going to subtract, so you get a positive 3y. You're going to subtract the 7, so you get a 2, set equal to 0, and that's going to factor into y plus 2 times y plus 1, giving you 2 possible answers of negative 2 and negative 1, which we will then go back, plug in, and see if they work. So the negative 2, let's write it this way because I got so much stuff happening. All right, so negative 2, when plugged into this guy, is going to give you a 0 in the radicals. That's just 0. Does 0 equal, let's see what's going on in here, you get negative 6 plus 7 is going to give you a 1. So 1 minus the square root of 1 is 1 minus 1. Yeah, that checks out. Okay. Where'd my other number? Oh, there it is. Negative 1. Checking negative 1. All right. Negative 1 and 2 is going to give you a positive 1. That's good. It's a real number, right? Because it's positive. And the square root of that is 1. Okay, now on the other side, negative 1 going in is going to give you negative 3. So that brings that down to a 4. The square root of 4 is 2. And what's happening here? Okay, we got a 1 on that side. But on this side, you're going to get 1 minus 2, which is actually a negative 1, so that is not true. So your only answer is going to be y is equal to negative 2. Okay, so we got to see a no solution, which was a weird case because of the imaginary number. That one's odd. You got let's see an example where you get 2 answers, and they both work, and you get to see one where only one of them worked. What I think is neat about this is where you get to see the one that doesn't work isn't because it's imaginary. It just doesn't Like you get this opposite when you create it. Okay, so just check them. Don't try and zip through those too fast. All right, then the last part of this. We already discussed all the graphing. Now this is the solving equations. The last portion of the test is it's going to be based on a word or an application problem that you haven't seen yet, and that might intimidate you a little bit. But the reason that you haven't seen it is because we don't want to mimic something that you've already really done. Okay, but don't freak out too much about this. When we give you word problems or applications of functions, you're going to get, so here's a copy of a worksheet that my class has used. You're usually going to get a formula to go with them. And that's what's going to happen here. You're going to get a formula, and then I'm just going to want you to find some letter that's in there, right? So in all the letters that are here, I might give you the R, might give you the H naught and the H, and even the K, and then just have you solve for T. So the formula could be provided for you. You got a lot of words that surround it, but just think of it as a general algebra problem and approach it from there. Now, also at the same time, don't want to make it sound like it's too easy of a problem, but don't freak out from it at the beginning. Just be open-minded to it, and you may find out that half of the question is really easy, or maybe the whole thing is really easy by just plugging in a few numbers and getting work. So here's another one where maybe I just want you to solve for S. Okay? Now, with that all said too, the graphing is straightforward stuff. We should be good at this by now. You should be getting 100% here. The equations, these are the problems to solve. You should be getting 100%. Those should not be issues, and then the word problem is not going to be the worst thing in the world.